This is the chain rule extended. In the previous video, I wrote down the wrong problem, as a matter of fact, and I didn't put the final answer. The actual problem, which is number 9, reads the following: S equals 4 over 7 pi times sine of 7t plus 4 over 3 pi cosine of 3t. That's the actual problem. The one I wrote down before, I wrote down the wrong problem. For this one, we use the chain rule. Because they're separated by addition, I can just take the derivative of this and take the derivative of that and then add them together. The derivative of this, because this is the numbers in the front, this number's in the front, I can just keep that the same. That's just a constant. And then I have to take the derivative of sine. Then I multiply that times the derivative of the inside, 7t. The derivative of the outside, the derivative of sine, is cosine, and then we keep that the same in the end. The derivative of sine is cosine. Now we do the chain rule and we take the derivative of the inside. The derivative of the inside, 7t, just becomes 7. Because it's 7 raised to the first, t raised to the first power, we take away 1, that makes that 1, the only thing left with is 7. So this becomes that right there. This part here, same idea, the numbers in the front. The derivative of cosine is negative sine. Keep the inside the same. Now we take the derivative of the inside, which in this case is 3. This is just a constant times t to the first power. T to the first power becomes t to the 0 power, which is 1. So we're just left with the 3. If I simplify this, this comes out to 4 times 7 over 7 pi. Because I take this and multiply it all the way across, that's just 4 times 7 cosine of 7t. Oops, 7t. There's this real quick. Notice the 7's cancel out. This becomes, I multiply this on the front because it's just multiplying all the way across. So this is 4 times 3 over 3 pi negative sine of 3t. Notice the 3 on the top cancel the 3 on the bottom. So simplifying, this becomes 4 over pi cosine of 7t minus 4 over pi sine of 3t. That should be the final answer. You can pull out a 4 pi if you want, and it'll just be 4 pi times, in parentheses, cosine 7 pi minus sine 3 pi. That's the final answer. Let's go down to number, I think the next one was number 11, which I hadn't done. Number 11 reads like this. Number 11 reads y is equal to 2x plus 1 to the third power times 3x plus 1 to the negative 4 power. This we can't, it's not the same because it's a multiplication. We're multiplying this by that. We're not just adding and subtracting anymore. Now we're going to multiply. The way we do multiplication, we still do the chain rule. What we do is we take the first number here, this first thing in parentheses, and we leave it the same. So it's first times the derivative of the second. We take the first, which is this one, leave that the same, times the derivative of the second. So I'm going to put the derivative of this one, whatever that may be. Then we add the second, which is that one right there. We leave that alone. Times the derivative of the first. whatever the derivative of this is. 2x plus 1 raised to the third power. So to fill this, to finally fill this equation out, we have to find the derivative of this. We have to find the derivative of that. The derivative of this part here is, this is also a chain rule. We bring the -4 to the front, keep the inside the same, and then we take away 1 from -4. That leaves us -5. Then we take the derivative of the inside of that part. The derivative of the inside, this goes to 0. This becomes 3. So we multiply that by the 3. That's the derivative of this part right here. Now we do the second part, second derivative, this part here. The second portion of this problem, we have to take the derivative of this. The derivative of this is, we bring the 3 down, we leave the inside the same, and we take 1 away from 3. That becomes to the second power. Then we take the derivative of the inside, inside the parentheses. The derivative on the inside is a 2. Because this goes to 0, is the power of the derivative of a constant is 0. The derivative of a constant times this is just, that becomes 1. Because it's 1, you take away 1, that becomes x to the 0, which is 1. So this becomes just 2. Simplifying a little more, this becomes -12, 3x plus 1 to the -5th. This becomes 6, 2x plus 1 to the second power. Now we plug both of these back into the derivative we're supposed to get. So this becomes, we wrote down before, 2x plus 1 third power times the derivative we found. The derivative we found to be -12, 3x plus 1 to the -5. That's that derivative there. Erase this. And then we had before, 3x plus 1 raised to the -4th power times the derivative what we found was, we found the derivative to be 6 times parentheses 2x plus 1, that raised to the second power. Now we can simplify this just a little bit. This becomes, let me think, this becomes, I'm going to bring the 12 out because I can just multiply all the way across. So this is a -12 times 2x plus 1 to the third power times, I'm going to put that on the bottom, the 3x minus 5, I'm going to put that on the bottom. Because the -5, the powers you can actually, if it's a negative power on the top, it becomes a positive power on the bottom. So let me erase that, put that on the bottom. So this becomes 3x plus 1 raised to the 5th power on the bottom. Plus, I'm going to bring this part to the front, 6 times 2x plus 1 raised to the second power. This is a minus power on the top, so I can put this on the bottom. X plus 1 on the bottom raised to the 4th power. Now you can go in different directions with this. Because we're adding these two, they don't have a common denominator. I guess you could simplify this a little bit more. If I take out from the top, let's say I take out a 6. And from the top I take out a 2x plus 1. to the second power out of both of these. And from the bottom, I take out a 3x plus 1 to the fourth power. On the inside, I'm left with minus 6 2x plus 1 plus 1 x plus 1 to the first power plus 6. Yeah, plus 6. No, plus 1. I took out a 6. And so on the bottom, if I take that out, I'm left with, actually they're going to be separate. So separate. I took out a 3x to the fourth, so this one I'm left with a 3x plus 1 to the fifth power. Because I took 4 out of this one, I'm left with 1. So I guess my final answer is, I guess that as best as I can simplify it, would be, that thing isn't going down. Final answer would be 6 2x plus 1 raised to the second over 3x plus 1 raised to the fourth power times minus 12x minus 6 over 3x plus 1 to the no power plus 1 plus 1. Yeah, as far as I can go, I guess. And that's your final answer. That was number 11. No, that was number, yeah, 11. Number 12. No, so my computer getting slower and slower as I get older. Yeah. Number 12. Y is equal to x to the second minus 7x plus 7 e to the 9x over 7. And they want you to find dy dx. This is actually this is simpler than it looks. This is again a product rule, but also a chain rule. It's first times the derivative of the second plus the second times the derivative of the first. So the dy dx looks something like this. First, which is, first we keep the same. First times the derivative of the second. The derivative of a natural logarithm is just the natural logarithm, the actual function repeated, times the derivative of this part here, of 9x over 7. So we're going to multiply that by the derivative of 9x over 7. The derivative of 9x over 7 is just 9 over 7 because the x goes to 0. It's like a constant, 9 over 7 times x. That becomes 0, that becomes 1, so we're left with just 9 over 7. And that's first times the derivative of the second. Now we're going to add the second, which is e 9x over 7, times the derivative of the first. The derivative of the first is the derivative on the inside of this parentheses. The derivative of that is 2x. The derivative of that is minus 7. And the derivative of that, we can do that because we're just adding. The derivative of 7 is 0. So we're left with that. There's some distribution that we can maybe figure out to simplify just a little bit. What I could do, this I'm going to rewrite a little bit. I'm going to write this like 9x squared minus 7x plus 7 e to the 9x over 7. That's going to be over 7. Because this we're multiplying the 9 all the way across, and the 7's in the bottom. So that's what that becomes. And then this becomes plus 2x minus 7 times e 9x over 7. The reason we can't really go that much farther is because we don't have a common denominator. But we can pull a trick. The trick is, if I multiply this piece right here by 1, I don't change anything, right? I'm allowed to do that as long as I do the top and the bottom the same. So I'm going to multiply the top and the bottom by 7. What does that do? Well, what that does is, this stays the same. 9x plus 2 minus 7x plus 7 e to the 9x over 7. That's going to be over 7. And the reason I chose 7 over 7, if there's 7 on the bottom, then I can add all the way across because I have the common denominator. But then I have to multiply the 7 times all the way because everything in here. So this becomes plus 7 2x minus 7 e to the 9x over 7, all over 7. Now that I have a common denominator, I can add all the way across. So I can write it like this. 9x squared minus 7x plus 7 times e 9x over 7 plus 7 2x minus 7. That's e x over 7. Now even a trickier trick. The actual answer is up here. That's the final answer. You can use that as the final answer, but there are different ways to simplify this. Notice that this is all over 7. Don't forget that. This right here and this right here I can add because they have a common coefficient, e to the 9 of the x. So what I could do is I'm going to go ahead and distribute this 9 into here. This becomes 9x squared minus, what is it, 63x plus 63 e to the 9x over 7 plus, and I'm going to distribute the 7. This becomes 14x minus 49 e to the 9x over 7. Because I have common, this is common with this, I can do this. I can take 9x squared 63 plus 63 plus 14x minus 49. and this way. Can't forget the over 7. Now in this parentheses, there are things that we can do. This stays the same. 9x squared. Can't do anything with that. Then minus 63x plus 14, I think it gives me negative 49, I believe. Check my math. I'm really bad at math. Just kidding. Yeah, 49. Minus 49x. So that, and that goes. And this give me 14, I believe. Plus 14. That e 9x over 7 over 7. And that is that's pretty much as far as I got. Which isn't bad. I mean, it's still simpler than that monster up there. That's the final answer for number 12. To number 13. 13 says the following. Find the of x equal to 8 plus x sine of x. Sine of x. The derivative, before we do that, I'm going to rewrite so you kind of understand what it is that we're doing here. This, a lot of students forget that this actually means this for the half power. That's what a square root means. That's the way to write it in mathematics. Now you know how to do this, how to do the derivative of this. You take the derivative of the full function, and then you derive the inside function, noticing that this right here is a product rule. It's first times the derivative of the second times the second derivative of the first. So that's going to be interesting when we actually do it. But to the initial one, we bring down the half to the outside part, and we leave the inside the same. That's the regular chain rule. So we multiply times derivative of the inside. The derivative of the inside is 8 goes to 0, so that doesn't appear. Now we have to take the derivative of this. The derivative is the first times the derivative of the second, which is cosine of x. That's the derivative of the second. Plus second, which is sine of x, times the derivative of the first. What's the derivative of x? Well, just 1, so that stays like that. That's it. That's all. We can actually combine these a little bit. We can, multiply across and all that. But this is the derivative as is. I probably can't simplify this. Maybe I can. If this is actually this negative 1/2 up here. Negative 1/2. I could rewrite it, I guess, make it look a little neater. This should be x cosine. And don't forget, I go away 1 away from half, so it's negative 1/2. Cosine of x plus sine of x. And that's over 2 times the square root of 8 plus sine of x. Yep, that's dy dx. Number There's 13. The last one for section 3.6, number 14. Find the derivative of this one. Cosine squared of 9 pi 8. Before we do this, again, reminder of the way we write it in mathematics. This actually is this. This whole thing raised to the second power. We write it this way because it's just, but this is the same as this. So this follows a chain rule. The chain rule says this: take the derivative side, which we know, we bring this down. We leave everything else the same inside. Cosine of 9t minus 8. Then we take the derivative of the inside. The inside being that. Cosine of 9 pi t minus 8. Notice one away from here, so that just stays a 1, which keeps that. Now we have to find the derivative of this. What is that derivative? That derivative of cosine 9 pi t minus 8. That derivative means the derivative of the outside. Outside being sine. The derivative of cosine is negative sine, keeping the inside the same. Now we take the derivative of the inside of the parentheses, which is 9 pi t minus 8. 9 pi t minus 8, the derivative of minus 8 is 0. The derivative of 9 pi t is 9 pi, because this is t to the 1. We take that 1 away, bring it out to the front. That becomes a 0, so that just becomes 1. So that's there, we're left with 9 pi. Now we plug this back in for this, and we're with cosine 9 pi t times the derivative, which we found to be 9 pi t minus 8 parentheses times 9 pi. Multiplying across as much as we can, just to kind of simplify it. This becomes this 9 pi multiplies times this, but it also multiplies times this. So now in the front, also a negative right here. So this becomes negative 18 pi. 18 pi. So that and that becomes negative 18 pi. Get rid of this. It becomes a positive. Let's multiply. So now we just multiply cosine 9 pi t minus 8 times sine pi plus 8. And that is our dy dx. Hope this is helpful. I'll start implicit differentiation in a couple minutes.